Hi guys, welcome to Algebra 1. We're on lesson 15 today. Woo, moving right along. Okay, so today we are talking about terms and coefficients and the distributive property. So first let's talk about some factors and coefficients. Look up here, I have 4xy. The numbers and letters stuck together, remember we've talked about that. What does that mean? It means you're multiplying them, right? So these are all factors. 4 is a factor of x, of y, so they're all factors. They could also be called coefficients. The coefficient is the number or the letter in front that everything else is being multiplied by. And because with multiplication you can change around the order of your variables, it does not matter in the order of your factors, it doesn't matter which one is considered the coefficient. So you could say that 4 is the coefficient of x and y, or you could say that x is the coefficient of 4 times y, or you could say y is the coefficient of 4 times x, or even xy is the coefficient of 4. With coefficients, there's two types. You have numerical coefficients, that's when your coefficient is a number. And you have literal coefficients, which is when your coefficient is a letter. Normally, especially in this book, we're just going to be viewing numerical coefficients. So when your coefficient is a number. And because we mostly are just going to be dealing with those, we drop the word numerical and just use the term coefficient. So in negative 15 PQ, we say that the negative 15 is your coefficient. In 81 XNZ, 81 is your coefficient. Now, let's talk about something called terms. You have learned the word term before. Terms really aren't a difficult thing to understand once you understand them, but they can be slightly difficult to define, so hang in there. A term, that's an algebraic expression, and then there's three kind of facets to it, and I'm going to read them from your book, page 76. The first one is that it consists of a single variable or constant. So that's one letter or one number, that's a term. So for example, 4 is a single constant. It's one number. So that's a term. X, that's also a term. It's a single variable. So this is a term, this is a term. So that's the definition number 1. Number 2, a term is the indicated product or quotient of variables and or constants. When it says constant, it just means like a number or something like that. Something that doesn't change, so that would be a number. A number is a number, it's not going to change. 4 is 4, it's not going to become 3, it's 4. So here, 4x. This indicates a product. What it means by indicates a product or quotient, that means that the simplified answer is going to be the answer to either a division problem or a multiplication problem, because a product is the answer to multiplication, quotient is the answer to division. So the simplified answer, once you know what x is and you multiply 4 times whatever x is, your answer is a product. It's the answer to a multiplication problem. So 4x together is also its own term, because the indicated answer is a product or quotient. All right, and then number 3, this is the one that's the trickiest. It's not hard, it just is easy to trick yourself. So the third one is the indicated product or quotient. So that means the simplified answer is either an answer to a multiplication problem or an answer to a division problem. So the indicated product or quotient of expressions that contain variables and or constants. So that would be these two examples, in the pink and the blue. So here I have 4x times a plus b divided by p. Once you know all of the numbers that your variables stand for, and you found everything, your final answer would be once you divide the numerator by the denominator. That would be your final simplified answer. So your final answer is the answer to a division problem. It's a quotient. So for that, this is one big term. Over here, same thing. Yes, you're adding here, so the answer to an addition problem is not a product or a quotient, but the answer to this whole term is a quotient because you have to divide by m, and then you have your final simplified answer. So this is a term. So each one of these is an example of what a term can look like. If I just had 3x plus 2y, this is not just one term because the answer to this is a sum. It's the answer to an addition problem, not a multiplication or division problem. This is a term right here because you're multiplying it together. This is a term right here because, again, you're multiplying it together, but not both of them. So this is two separate terms, okay? Let's keep looking at this. Look at x plus 4xym minus 6py plus 2 minus 8. How many terms are in this expression? 4, that's right, 4 terms. You have your x right here, which I'm going to go over it again in black so you can see it even better. You have your x, so that's one term. Then you have positive 4xym. And in this study of math, we're going to always keep the sign that's right in front of the term as a part of that term, so that it's especially important with negatives, okay? So the sign is always a part of the term, goes with the term. So this term is negative 6p divided by y plus 2. That's term number 3. And the last term is negative 8. So we have our first term, second term, third term, fourth term. So I have 4 terms in this expression. Okay, do you understand how that works? Does that make sense to you? If not, excuse me, if this is confusing to you, please let me know and we can keep going over, we can keep doing other examples, other problems. Okay, now we're going to keep going learning about the distributive property.